So in this video, we want to look at examples of calculating limits at infinity. So let's look at this first one. The limit as x tends towards infinity of x squared minus 5x plus 7 divided by 3x squared plus 6x. So the main idea is to exploit the fact that the limit as x tends towards infinity of 1 over x is equal to 0. So how do we use this? The idea is to divide every term in this fraction by the largest power of x. So in particular, in this example, we see that that power is x squared. So we'll write this as the limit as x tends towards infinity of x squared over x squared minus 5x over x squared plus 7 over x squared. Then we'll have 3x squared over x squared plus 6x over x squared. Okay, so let's now simplify these. We'll get 1 minus 5 over x plus 7 over x squared. We'll have 3 plus 6 over x. And now if we use this idea here, what we see is that this term will go away, this term will go away, and that term will go away, and all we'll be left with is 1/3. Okay, let's look at another example. So we'll apply the same idea. Here the largest factor of x is x to the 9. So we'll write this as the limit as x tends towards infinity of 1 over x to the 9 minus 3x to the 9 over x to the 9, then 2 over x to the 9 plus x over x to the 9 plus x to the 9 over x to the 9. And then this is just 1 over x to the 9. The x to the 9s will cancel, so we'll get a minus 3, then 2 over x to the 9 plus 1 over x to the 8 plus 1. And just as we saw before, this term cancels this one, and that one will cancel as well. And all we're left with is minus 3 over 1, but that's minus 3. Okay, let's have a look at another example. So here we have the limit as x tends towards infinity of e to the x. So what we have to kind of worry about here is that idea no longer applies. This idea of using this trick that the limit as x tends towards infinity of 1 over x goes to 0. So what we have to do here is use a form of L'Hopital's rule. So to apply L'Hopital's rule, there'll be a separate video on L'Hopital's rule shortly, by the way. We need to check that we get an indeterminate form. So if we put this in, what we see is that that e to the x goes to infinity and x goes to infinity. So this thing is an indeterminate form, meaning it could be anything. We just don't have enough information on the face of it. So L'Hopital's rule says that we can just differentiate the top and differentiate the bottom and then calculate the limit. So the derivative of e to the x is e to the x, and the derivative of x is 1. So this is just the limit as x tends towards infinity of e to the x, but that is infinity. So in this case, the indeterminate form is equal to infinity. And that's it for this video. If you like the video, please hit the like button, and if you're new to the channel, please consider subscribing. If you have any questions, feel free to leave them down in the comments below, and if you have questions that you think other students might find useful, you could also include those in the comments down below as well. There will eventually be notes to accompany this video in the video description. Thanks, guys.